Hello everyone. Hello, yes. So hello my dear students, I welcome you to NEET World. So today we will be discussing NEET 2023 chemistry question paper. Okay, so in the last session we have discussed 2022, 2021 and 2020 and 2019 also. Okay, so let's start our 2023 paper discussion. Here the first question we have here is, so just check, let me check whether everything is clear or not, audio, video. Yes, okay. So here the first question here given is, for a certain reaction, rate of the reaction is given like this: rate equals to K into concentration of A to the power 2 and concentration of B to the power 1, like this they mentioned. Okay, when the initial concentration of A is tripled, so here A, let us say this is the equation 1 which they have mentioned. Now if initial concentration is A, now they are saying it is tripled, it means I am writing 3A. Okay, so I am writing it as 3A. So 3A into, again next, triple, keeping the concentration of B is constant, B concentration is remain constant. Okay, so what is here we have square, right? So K R. So now what happens here, let us say this is R2. So R2 will be 9 times of K A square, like this. Okay, now look here, this is nothing but, this part is nothing but equation 1 only now. So let us say this is R1. So how this R1 and R2 are related? So now R2 is equals to 9 times of R1. So look here, what they are asking again, the triple, the concentration of B remains constant. The initial rate would be, what happens to initial rate? So initial rate is, now when we compare with the final rate and initial rate, so final rate will be 9 times of initial rate. So initial rate is increased by a factor of what? By a factor of 9. So we can go with option number 2. I hope it is clear without any confusion. Okay, then next, let me check, any other issues are there? No. Next thing is, given below two statements, one is assertion, other one is reason. Okay, so now assertion is metallic sodium. So when metallic sodium is dissolved in liquid ammonia, so when it is dissolved in liquid ammonia, so now what happens here is, so it will forms NaNH2. Okay, and see, when sodium, whenever sodium is treated with some other species, what happens? It releases H plus, like electrons, like it becomes Na plus and electrons are released. Okay, so here Na plus NH2 minus. Now this liquid ammonia also surrounds around this electron, so we can say ammoniated electron here. So it will be like this, NH3 some X times. Okay, like this. So we got two things. So due to this reason, so due to this like electron which is released from sodium, which is surrounded by this ammonium, this solvent ammonia, liquid ammonia. So now the solution shows paramagnetic nature. What nature? Paramagnetic nature. So now what they are asking here, sodium dissolves in liquid ammonia giving a deep blue color. Yes, this solution, this paramagnetic solution is what? Deep, like having deep blue color. Okay, so which is paramagnetic nature. Yes, this is correct only. Now the deep blue color is due to formation of amine. This is not due to the formation of amine, this is because of the ammoniated electron in the solution. So reason is incorrect, but assertion is correct. So A is correct, but R is false. So you can go with option number 2. Okay, then next, this is also easiest, one of the easy question. So look here, conductivity of centimolar solution. So K conductivity represented with K, right? At 25 degrees is this much. How much K? 0.0210 ohm inverse centimeter inverse. Next, and the resistance of the cell containing the solution is, resistance, how can we say? R, which is equals to 20 ohms. Okay, then the cell constant value is, so cell constant value, let us say G star. So G star equals to how much they are asking. So G star we can also say L by A is nothing but G star. It's the ratio of length to area. Okay. Now what is the relation we have for this? So we have a relation K equals to G into G star. So where G star represents the cell constant and G represents here, so I am writing G represents conductance, or I can say that is inverse of resistance. I am writing 1 by R. Okay, here G star, here K. So what we need to find now? We need to find this G star now. So G star equals to K into R. That's it. We got the answer. So what is the K value mentioned? 0.021 into R mentioned 60. Here ohm inverse, here ohm, get cancelled. So we will be having centimeter is a centimeter inverse is a unit which we have in the options also. Okay, so it means we are doing it correct only. Okay, now 0, remove it. So then we will be having 6, 12 like this. Okay, 1 0. So 2 decimals are there. So I can write it in this manner, centimeter inverse. So I hope it is clear. So option number B we have, 2 we have, so that will be the correct for this particular question. I hope there is no confusion. I hope everything is clear, right? Okay, then next. So whenever we have carbonyl group, functional groups, so when we are treating with zinc amalgam in concentrated HCl, so what happens here? So this is what? Clemmensen reduction. What is that? Clemmensen reduction, which we already discussed about this thing in the hydrocarbons chapter, right? Okay, so what happens in the Clemmensen reduction? Carbonyl carbon, I mean this carbonyl group will be converts into CH2 group. So CO group is converting into CH2 group. So wherever you have double bonded O, remove that and replace it with the 2 hydrogen atoms. That's it. So look here, if we remove and if we replace with the 2 hydrogen atom here and here, so it will become like this, one side, and this side also it will become these 2 oxygen atom is removed and 2 hydrogens are replaced there, right? So this is what the compound we are getting. So what is our A? Fourth option is the most appropriate answer here. Okay, always remember in Clemmensen reduction, zinc amalgam in acidic medium used where the carbonyl group is converted into like hydrocarbon chain. If there is CO bond, that will convert into CH2 bond. That's it, CH2 group. Okay. Now, if the same process if we want to do in the basic medium, we need to use Wolff-Kishner reduction. So where we will be using hydrazine NH2 KOH, basic condition upon heating, under heating condition. So same process happen, the CO groups convert into CH2 group. Remaining part will remain same, the only CO groups will be converted into CH2 group form. That's it. Okay, so what is that reaction? So it is Wolff-Kishner reduction, this is Clemmensen reduction. See, these things already we are discussed very clearly in the hydrocarbon chapter. Okay, you can refer that playlist where you will be having everything regarding this hydrocarbon part. Then next, which of the following is an example of heterogeneous catalysis? So heterogeneous catalysis means, so you can directly consider the substrate and substrate and product and like here catalyst we are using now, that will be having different phase. I mean if this substrate product, if let us say they are in the gas phase, if the catalyst is in the solid phase, so we can say that is a heterogeneous catalysis. If all these things, substrate, product and catalyst are in same phase, let us say all of them are in gas phase, so we can say that is homogeneous catalysis. So if everything is having same phase, we can say homogeneous. If any one of this is having different phase, then we can say heterogeneous. Okay, let us see here. Hydrolysis of sugar catalyzed by H plus ion. Okay, next, decomposition of ozone, presence of nitrogen. So ozone, nitrogen monoxide, everything is gas. Okay, so it is homogeneous. Combination between dinitrogen and dihydrogen to form ammonia in presence of finely divided iron. It means N2 plus 3H2 gives rise to 2NH3. This is what Haber's process we are doing now. So during this process, finely divided iron is used. So iron is in solid state and these are in the gas phase. So what we can say, this is heterogeneous catalysis we can say. So we can go with option number 3. Okay, so the remaining will be having, see, same phase, it is having gases only. Okay, next thing is given below two statements, one is assertion reason. Helium, yes, in 2023 paper relative to the other papers, it is having more assertion reason questions. Okay, you can also focus on this assertion reason questions at this last moment to get more clarity while solving them. Helium is used to dilute oxygen in diving apparatus. Yes, so we know scuba, like sea divers will be there now. So those who go under the water. Okay, so what they will carry? They will carry oxygen cylinder, right? So in order to dilute the oxygen in the cylinder, they will be using helium gas, which is inert gas, helium gas. Okay, so it will be having very low solubility. What I am saying? Very low solubility, but they have mentioned here it is having very high solubility. This reason is incorrect, but assertion is correct. So why do they dilute? Because we know, we studied about Henry's law. So what happens? So if pressure is increases, solubility of gas also increases. So in when they are going for diving purpose, so what happens? Due to high pressures, so solubility of oxygen in the blood will be more. Therefore that will makes a bubble to form, like it will create the bubbles, or solubility of oxygen will be more. So that creates uncomfortness, right? So due to that reason, they will dilute the that oxygen cylinder, okay, using helium gas. Okay, because it is having low solubility. What they told? They have high solubility. So this is reason is incorrect, but assertion is correct. So I can go with A is true, R is false. You can choose option number 2. Next, among the following, the total number of species not having 8 electrons around the central atom. Yes. So ammonia, so nitrogen with lone pair and 3 hydrogen atoms. So 3 bonds with the 3 hydrogen atoms, so 6 electrons plus 1 set of lone pair, so 2 electrons, total 8 electrons. So it is having 8 electrons. For AlCl3, aluminium group 13 element, so it has valence electrons 3 and surrounded by 3 other atoms. Therefore each bond contains what? 3 electrons, 2 electrons, each bond contains 2 electrons. There are 3 bonds, 3 2s are 6 electrons are there here. So I can choose, this is not having this is having lesser than the octet, I mean 8, less than the 8 electrons. They are saying not total number of species not having 8 electrons. Yes, this one is not having. Similarly for this one, so CCl4 carbon having 4 valence electrons, 4 surrounding atoms are there. So for like 1 electron from each of these, therefore 8 electrons will be there here. Okay, so this is having 8, this is also having 8. So AlCl3, BeCl2, and for PCl5 there are 10 electrons you can count. Okay, so 1 2 3, so 1 2 3, so option number 4. So that will be the proper answer for this particular question. Next, for N2 molecule, what is the energy orbital diagrams? I mean, what is the energies of the molecular orbitals? So what is that? Sigma 1s we should write, sigma star 1s bonding and anti-bonding. Always anti-bonding will be having higher energy than the respective bonding, like this. Next 2s, sigma 2s, then next sigma star 2s, okay, like this. Okay, total number of electrons in nitrogen is like N2 molecule is 14, right? So whenever we have 14 electrons or less than 14 electrons, follow this order. So sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Next pi 2py equals to pi 2p x equals to pi 2p y. Okay, you can write this. Then next sigma 2px, sigma 2pz, let us write. Okay, then next pi star 2px equals to pi star 2py, and finally highest energy is for sigma star 2pz. So this is what the order we need to follow. And where do we have this kind of option? Sigma 1s, sigma 2s, pi 2px equals to pi 2py. This is incorrect. Okay, again, no. So look here, sigma 1s, sigma star 2s, which is having similar to this. So option number 4 will be the correct for this particular question. I hope it is clear, there is no confusion. Next, diamond will be having all carbons with sp3 hybridization, right? And the next, fullerene is having hexagons and pentagons, condensed form of hexagons and pentagons. Okay, so it will be having cage like structure. C60 fullerene if we take, it will be having 12 pentagons and 20 hexagons like this. Okay, so cage like structure we can say. Graphite is used as lubricant. Okay, it will be having very weak forces of interactions between the layers, therefore it is applicable used as a lubricant. Okay, next coke will be used as reducing agent, so A3 B1 C4 D2, that's it. So D2 C4 B1, so option number 2 is correct for this particular question. Then next, here number of sigma electrons, sigma bonds, pi bonds and lone pairs in pyridine. So how can we draw the pyridine structure? Yes, this is the pyridine structure na. So now draw it, represent all the hydrogens also, all the atoms, therefore that will give us more clarity here. So count number of sigma bonds now. So 1, 2, 3, 4, 5 sigma with hydrogens, carbon and hydrogen. So 5. Between each carbon also we have, and between nitrogen and carbon also 1, 2, 3, 4, 5, 6. So first 5, now 6. Total 11 sigma bonds are there. Okay. Now how many pi bonds? 1, 2, 3. So 3 pi bonds are there, and one lone pair on this nitrogen. One lone pair. So do we have any option like this? 11, 3, 1. So I hope it is clear without any confusion. Next, element expected to form largest ion to achieve the nearest noble gas configuration. Yes. So in order to achieve the nearest noble gas configuration, write what are the species here. So fluorine now. So fluorine atomic number is 9. Nearest noble gas is 10. What is that? Neon. 10. So in order to get this 10 electrons, it should become F minus, right? Therefore 10 electrons are there. So which is nearest noble gas configuration? So it is F minus. Similarly for oxygen, it will be what? It will be what? O2 minus, because it is having 8 electrons but we require 10 electrons. So it will be O2 minus. For nitrogen, atomic number is 7. In order to make 10 electrons, it will become N minus 3. Okay. And for sodium, atomic number is 11. In order to gain become 10 electrons, it will become Na plus. Like this we can write. So now these species are what? These are now having 10 electrons in them. So 10 electrons they have. Now I can say all these things are what? Isoelectronic species, same number of electrons containing species. So for a species, like for a set of species having same number of electrons, more is the negative charge, more will be the size. Okay, so it is having only 7 protons and 10 electrons, therefore electron cloud will be expanded here, therefore it is having larger size. So what is the size order? N minus 3, O minus 2, F minus, and the next Na plus. This is what you need to write here. So what is the correct suitable answer? Largest ion is N minus 3. Nitrogen will be achieving the nearest noble gas configuration with the maximum size. Okay, next. A reaction can have, see again assertion reason question. I think this is third question. Okay, on assertion reason based. Okay, a reaction can have 0 activation energy. Yes, some free radical reactions can have 0 activation energy, and some what is that? Radioactive reactions, few radioactive reactions also having 0 activation energy. Okay, now the reason again look here, the minimum extra amount of energy absorbed by reactant molecules so that their energy become equal to threshold energy is called activation energy. Yes, this is also correct. Both assertion and reason are correct. Okay, assertion and reason are correct. The minimum extra amount of energy absorbed by reactant molecule so that their energy becomes equal to threshold energy. Okay, so reason is also correct only, but there is I think there is no proper explanation about the assertion. So both A or R are true, A or R are true, but R is not correct explanation of A. So I am going with option 1, because he was not explained exactly what exactly assertion meaning is, not given in the reason. Therefore I can say both are true statement but not the correct explanation. R is not the correct explanation of A. Next, see, every time we will be seeing one question on this kind of this kind of mechanism based question. See, HBr is there, alcohol is there. So what we need to add? HBr is a strong acid, it liberates H plus ion. Now here in the substrate we have OH now. So this H plus, this OH minus removed as water molecule, and what is the remaining thing? This water molecule is removed using this OH and this H plus. So we will be getting a carbocation like this. Look at here, CH3, here let us say positive charge we got. Okay, now look here, this is secondary carbocation, this is secondary carbocation. Okay, now if see here you should have some confusion also sometimes, like whether it is elimination or substitution or addition, what happening here. See, after removing OH minus, using this H plus, we are remaining with Br minus, right? Okay, so this Br minus, see, there is no proper eliminated product, so you should not get any confusion regarding this addition or elimination or substitution. So OH minus H plus is removed as water and we are remaining with Br minus. So if we consider this as base, there is no appropriate eliminated product when we remove one proton from beta position. Okay, so that is not the elimination reaction, it is something like substitution reaction. So we got a carbocation like this. Now I can transfer this hydrogen from here to here. So after getting transferred that hydrogen, so what is the carbocation we are having here? CH3. This hydrogen is transferred from here to here and we are getting a positive charge on this carbon. So why it is happening like this? Because this carbocation is what? Tertiary carbocation. So if it is tertiary carbocation, that will be more stable than this secondary, right? Okay. Now what are the other thing we have? We have the negative part, Br minus. So Br minus will attack on this carbocation and will give the final product. Yes, tell me what is the final product we have? The Br minus attached to the tertiary carbon. So we have only option number 4. So that will be the correct answer for this question. I hope it is clear. Fourth option is correct. Okay. The next. Next, look at here. Given below two statements, one is again assertion reason. In the equation, delta G equals to minus NF E naught E cell is given. The value of delta G, yes, value of delta G depends on N value, they are saying, yes. Okay, number of electrons, N represent number of electrons participated here. Okay, so E cell is an intensive property, yes, and delta G is extensive property, yes. E cell is intensive, E naught cell also, and delta G is extensive. Okay, so now reason is correct, assertion is also correct, and see, delta G depends on N value, that is also correct. So I can say both A and R are true. Both A and R are true. See, equation delta G, the value of delta G depends on N, yes. The intensive, delta G is an extensive, yes. I can go with option number 4, A and R are true, and R is the correct explanation of A. Next, which among the following options is correct graphical representation of Boyle's law? So what exactly Boyle's law? P is inversely proportional to V at constant temperature, T is constant, right, in this process. So these the two P and V are having inversely related to each other. Okay, so whenever we are drawing P versus V curves, PV curves, so it should be like this. Okay, so if increase in pressure should decrease the volume, like that. Okay, so we have that kind of graph here, and if we want to draw P versus 1 by V, so if it is P versus V, we should get a graph like this. If I say P versus 1 by V, P versus 1 by V means it should be directly proportional now, so it means we should get a graph like this. Okay, so here we need to check from this. Okay, see, we know during this process temperature is constant. Here they mention temperature, so this has to be remain constant, here it is changing. So this is not a Boyle's law graph. Okay, here PV curve here we have here and here. Okay, so now we have PV equals to nRT. This is what the ideal gas equation we know, right? Okay, from this P equals to RT by V if I write. Okay, so I am writing P, see here I am writing P is inversely proportional to V and directly proportional to T. Okay, so in PV graph, in P versus 1 by V graph, yes, this should be the graph we get, but if with increase in P, what we need to check, temperature should also increases. See, if I draw a graph here like this with increase in P at a particular volume, see, so we should get P here. If I say this is P3, so P3 is greater than P2 and this is P1, means P1 is the least like value. So higher the P, higher the T should be there. So T3 should be greater than T2, then T1. That's it. I hope it is clear. So first option is clear here, right? Whereas see, 1 by V graph should not be like this now. 1 by V should not be like this. It should be a curve like this. 1 by V means P versus 1 by V graph will not be like this. So here PV graph is given, but they have given at higher pressure, see, higher pressure, temperature should be high, but they mentioned that T1 is the least, so this is also not the suitable one. I hope it is clear. Next, Lissagne's test. Here organic compound containing both nitrogen, sulfur are present. Okay, so whenever we are treating this, see, organic compound means carbon will also contains, no? So whenever treating this with sodium, we will be getting NaSCN. This one is formed. This is an ionic compound now. Okay, now Na plus SCN minus will be there. So whenever we are treating with this with Fe plus 3 solution, okay, so we will be getting Fe SCN 2 minus plus 2. So this is what blood red color solution. This is what blood red color solution is formed. So that is option number 3. Okay, so this will be there coming from where like we will studying some basic concepts of chemistry, organic chemistry, right, in the 11th standard. So there will be having qualitative analysis and quantitative analysis. There will be studying about this. You can revise. So I can relate this to the practical organic chemistry part, right? Okay, so give a try for this question. First one is diazonium salt is there. We are treating this with what? Cu2Br2, Cu2Br2 and HBr. So this is what Sand-Meyer reaction. So what happens there? Just give a try. So here from these we will be having Br minus. Okay, so N2 will goes out with these electrons. So here Br minus will be replaced in the place of N2. So we are getting a product like this, bromobenzene we are getting. So this process is what? The first process is what? Sand-Meyer reaction. Okay, and second one we are having magnesium in dry ether. So this will be gives us like a Grignard reagent, a RMGX type product, aryl group MgBr. Okay, now this one, so we know magnesium will be having positive charge plus 2, this is minus 1, and here the carbon which is attached to this, this benzene carbon is also having negative charge now. Okay, so upon treating with the water, okay, what happens? So here it will release H plus and OH minus now. Okay, so this H plus is taken by this carbon which is having negative charge and forms a benzene ring. So this is what? Benzene ring is obtained. So our product will be benzene. Okay, hope it is clear. Next, correct statements from the following. Atoms of all elements are composed of 2 fundamental particles. Is it true? No. Atoms, what are the main fundamental particles we know? So we know that electron, proton, neutron are there, na? But he is saying only 2. Here basically it is having 3. Okay, Next, the mass of electron is 9.1 into 10 power minus 31 kg. Mass of electron, this is correct only. Okay, all the isotopes of a given element show similar same chemical properties. This is also true. Okay, protons and electrons are collectively known as nucleons. No, protons and neutrons are collectively known as nucleon, but not the electrons. Dalton's atomic theory regarded the atoms as the ultimate particle of matter. Yes, this is correct. So BCE, correct, BCE, option number 3. Next, anyway, solid state we are not going to solve. Anyways, here it will be having again easy also. CCP means what? So B atoms will be, CCP will be having 4 B atoms, and A occupies, tetrahedral voids are 8. So out of that 8 by 3 you can take. A atoms are 8 by 3, B atoms are 4. So like this we can do. So B1, 2, so A2, B3. So this is what the answer. So 2 plus 3, how much we got? So 2 plus 3 is 5. So 5 will be the option for this. Okay, I hope you know about FCC lattice or cubic close like CCP lattice, all these things. So based on that, this question can be solved. Okay, so you can focus solid state for EAPCET. 1 or 2 questions you can expect in the EAPCET. Okay, next, a unit formed by the attachment of base to 1' position of sugar is known as, yes, sugar plus what is this, base is considered to be nucleoside. So where it is attached, first position, right? This is correct only. Okay, when the nucleoside is linked to the phosphorus acid, they are saying, is it phosphorus or phosphoric? So it is phosphoric acid. Like phosphorus means it will be having H3PO3. This is us acid. So when I am saying phosphoric, it will be H3PO4. Okay, so in the phosphate group which we are seeing in this nucleotide will be having phosphate group, that is coming from this phosphoric acid, that will be like this. Okay, O minus O, which is attached with the 5' of this sugar. So that we can call it as, what is this, phosphate group having thing is called nucleotide. So here it is phosphate. From where this phosphate comes from? Phosphoric acid, not from phosphorus. So option 2, statement 2 is incorrect because of this phosphorus. It should be phosphoric. So statement 2 incorrect, statement 1 is correct. Okay, 1 correct, 2 false. So option number 2. Among the following, polymerization produces neoprene. So remember, neoprene comes from chloroprene. So chloroprene will be having structure like this. This is a chloroprene. So option number 1. So what is the monomer unit of neoprene? It will be chloroprene. Okay, this is stability factor. Okay, so this question is based on inert pair effect. Inert pair effect. So what is inert pair effect? IPE. Inert pair effect is what? So the tendency to the inertness of ns pair electrons to take part in the bond formation. So for example, p block elements will be having ns electrons and np electrons, right? Okay, so p block elements will be having ns electrons and np electrons in their valency. Let us say 13th group elements. When I am saying 13th group elements, what are the elements? We have boron, gallium, boron, aluminium, gallium, indium, thallium. So you can remember Bagh it. Bagh it. It means this is the 13th group element code word. Bagh it means boron, aluminium, gallium, indium, thallium, like that. Okay. So now here it is mentioned. So what is the general electronic configuration? NS2 NP1. So 10 plus 3 electrons are there na, 13th group means yes. Okay. So for boron it is 2s2 2p1, like that. Okay. Now this is a general electronic configuration. So as we move down the group, what happens? So only NP electrons will take part in the bond formation, and there will be reluctance or inertness to this NS pair electrons. They won't show participation towards the bond formation. They won't involve. So I can say inertness of this NS pair electrons is called inert pair effect. Okay, so therefore down the group, like this thallium if I say, so it will only forms compounds in, thallium will show participate the compounds in +1 oxidation state more effectively than this +3 oxidation state. So all the thallium +3 complex, I mean all the compounds of +3 oxidation state in which thallium is having +3 oxidation state are highly unstable. These are highly unstable, only +1 is stable, like that. Okay, so if I say gallium, indium, thallium, like this, so I am writing +1 +1 +1, and gallium, indium, thallium in +3 oxidation state. If I write like this, so down the group what I am saying, inert pair effect increases. So inert pair effect is more for thallium, therefore it will show, it will have only +1 oxidized state compounds, lesser oxidation number containing compounds are formed. Therefore, so thallium will be having stability, more stability in +1 than indium and gallium. So when it comes to higher oxidation state, higher means if I remove 2 electrons from here and 1 electron from here, we will be getting +3. So +1 will be whenever the compound is forming only by using NP electrons but not from the NS electrons, we will be having oxidation states like this. So in this case, so this will be the reverse, order will be reverse. Higher oxidation stability decreases down the group, lower oxidation stability increases down the group in the p block elements due to inert pair effect. This is the concept here you need to remember. So this is applicable to other groups also, like for carbon family also it is applicable, same story. Okay, so you should not get confused or should not get forgot about this topic, because you can see repeated questions on this kind of topics from p block. Okay, so now here look, they directly mention thallium iodide like this, thallium iodide 3. So which is stable out of these 3? We know thallium iodide is more stable but not this one. So they are saying correct relation. See here they mentioned in the reverse order, so this is incorrect. Okay, and see this should be in the reverse order now. For the higher elements +3 aluminium like this, +3 will be more stable, not the +1. So this is also incorrect. Here this is also incorrect. So most appropriate answer for this will be third option. Okay, barbiturates. So barbiturates, which one of the following belongs to barbiturate? So this is static question again from your 12th class. What is that? Chemistry in everyday life. So where we will be having barbiturates in veronal. So you can directly go with that. So it based on the structures, you just go through the book, it will be there, everything given in the NCERT book with the structures. Next, not correct statement. Hydrogen used to reduce the heavy metal oxides to metals. Okay, let us go further. Heavy water is used to study the reaction mechanism. What do we mean by heavy water? It is D2O. Yes, this is correct only. Okay, next, hydrogen is used to make saturated fats from oil. Yes, this is also correct only. So we'll see some conversion of oils like used to make saturated, from unsaturation to saturation. How can we make, like more number of double bonds, triple bonds are containing, that we can convert into like saturated. We can add hydrogenation, we can do hydrogenation process, no? So that means that is also correct. Okay, C also correct. So they are asking about not correct one, right? Okay, the HH bond dissociation enthalpy is lowest compared to the single bond between two atoms of, no, HHs will be having hydrogen, one s orbital, both are of same energies and very close to the nucleus. So this overlapping will be very strong. Okay, this will be having high energy but not the low energy. Okay, this is incorrect. So we have option D in here. Okay, anyways, B is correct, C is correct, B, C correct. So this is not the one, not correct they are asking. B is correct, this is not the one. B is correct, C is correct, this is also not the one. Yes, so based on that we can directly choose this. See, hydrogen reduces metal oxides that are more reactive than iron. No, right? In the electrochemical series if you see, so see more reactive metals it won't reduces. Okay, so more reactive metals will act as strong reducing agent. So that will only reduces others, that metals will undergo oxidation. So statement E is also incorrect. So E, D, D, E. So you can choose option number 2. So in these cases, whenever you are seeing some confused kind of statements, just eliminate using the known options you have. So you are well aware of few options at least, so you can go with the help of those options, those statements. Okay. Next, intermolecular forces of attractions and repulsions between the interacting particles that will include. Okay, so intermolecular forces, say they are saying intermolecular forces, they are not saying about bonds. Intermolecular forces like dipole-dipole interactions, hydrogen bonding, van der Waal interaction, those things, right? So dipole-dipole is intermolecular forces between the molecules, dipole induced hydrogen bonding, dispersion forces. Covalent bond, this is, they are talking about covalent bond. This is not the covalent bond, is purely a bond formed by sharing of electrons, whereas hydrogen bonding, these are formed by the hydrogen bond formed by electrostatic force of attraction, which is a intermolecular force. So C, B, A, E are the intermolecular forces, C, A, B, C except D. So option number 2, except D, everything is intermolecular force in the given options. Yes, among the following given options, which one of the following molecule act as Lewis acid? Easy, right? How can we identify Lewis acid? It should contain like one vacant orbital, or which is that should contain one vacant orbital. Like see, it is electron deficient, it is having only 6 electrons, one p orbital is empty on the boron in the BF3, therefore it can accept a pair of electrons, so it can be a Lewis acid. Whereas water is already having non-bonding electrons, it can only donate, so I can say this is Lewis base. NH3 also having lone pair electron, it can be also Lewis base, and OH minus is having negative charge, that can also donate it. So this 1, 3, 4 are Lewis bases, whereas 2 is Lewis acid. Next. Again, similar kind of question is seen in the last paper also, 2022 paper also. The right option for the mass of CO2 produced upon heating 20 grams of 20% pure limestone. Let us say CaCO3, they given reaction also, upon heating 1200 degrees Kelvin, 1200 Kelvin temperature, it will produce a CaO and CO2 gas. Okay, for every 1 mole we are getting 1 mole of CO2. For every 100 grams, it means molecular weight of this compound is 100. For every 100 grams we are getting 44 grams of CO2. Now what they told, 20 grams is heated. So 20 grams is heated, so how many grams it is producing? So if it is 100% pure, this is the scenario. Okay, so we need to find the x value here. So how can we find x here? X equals to, just use the unitary method, 44 into 20 by 100. Okay, this is the scenario when it is 100% pure, but they told 20% pure now, so 20% like this we should take. Okay, so 0, 0, 2 zeros. Okay, then next this will be 50. Okay, we have 88 by 50 we have, so I am writing 8.8 by 5. So this will be how many times? So this will be how many times? 88 by 8.8 by 5 means 1. So we can have here 3.8. So we can put 38 will be having. So it will be 7. So 1.7. Yes, only one option we have. Option number 1, 1.76. That will be our answer. Okay. I hope it is clear. How can we do using this unitary method? Everything is clear. So similar kind of question we have seen in the last paper also, 2022 paper also. If you haven't watched yesterday's question paper discussion, that is on 2022 NEET Chemistry. So you can go and watch that video also after completing this session. Okay. So see, we are going to write 2025 means you should aware of this 2024 paper, which we are going to discuss tomorrow, and 2023 paper, 2022 paper. At least these 3 papers you should focus more at this point of time. Okay. Now the relation between NM. NM means what? Number of permissible values of magnetic quantum number. See, generally we will use indicate magnetic quantum number M. Okay. For values we will say ml. Okay, but here they are saying m, nm they are using, whatever it is, for a given value of azimuthal quantum number. Azimuthal quantum number means L. So ml values will be taken as 2L plus 1, right? So this is what the formula we will be using. So instead of saying ml, so in this case they are saying it as nm. So I am taking it as 2L plus 1. So this is the formula. Do we have any relation like this? No relation is mentioned in this format. So we need to convert into some other forms in terms of L. So I can write 2L equals to nm minus 1, okay, then L becomes nm minus 1 by 2. So this will be the proper relation which is there in the option 4. Okay, I hope it is clear without any confusion. Yes, next, done. Okay, which of the following statement is correct? So all enzymes utilize as, correct they are saying, utilize ATP in phosphate transfer required calcium. So this is not calcium, right? It is what? Magnesium. So the bone in the human body is inert and unchanging. No, this is not the suitable, like it is not the correct one. So magnesium plays a role in neuromuscular function, okay, the daily requirement. Yes, so this is what 200 mg to 300 mg will be given in the book, right? Okay, but here it is given in terms of grams with the same one, so we can write in the grams also. So I can say this fourth option is most appropriate for this particular question. Next, cyanides, alkyl cyanides upon treating with lithium aluminum hydride, reducing agent, and followed by hydrolysis. So it is strong reducing agent, converts the cyanides to, whenever we have cyanide like this, so lithium aluminum hydride, okay, so lithium aluminum hydride converts it into amine, CH2NH2. This will be the product formed. Okay, now whenever we have what they are not give primary amine, so this is primary amine, right? Yes. So in the second case it is isocyanide. So process will be same, but see it is iso form, so it means here it is like this. Okay, so what happens here, same lithium aluminum hydride, it will also reduces to respect to amine. So we will be getting this kind of product. This is what? Secondary amine. This is what? Secondary. This is primary. So if it is secondary, so they are saying not produce primary. So second option will be the most correct. Okay. So whenever we have amide, see CH3CONH2. Okay, so this what happens here, it is also produces, see, primary amine will be produced. So this is Hoffman degradation product now. So on treating with Br2 KOH or NaOH, or sometimes they will be mentioning it as NaOBr. This is also no issue, hypobromous acid we can call. So this mixture is nothing but given as like this also, NaOBr. Okay, this will be the product formed when these two reacts. So in this case what you need to do is, the name of this particular reaction is called Hoffman bromamide degradation. So just remove this CO group. If you are removing that CO group, we will be having this one, methylamine. This will be the product, primary amine. So it will be giving primary, this one also, but this is giving secondary. So go with second option. Next, given example of, given compound is an example of, see, halogen attached to the alkyl group having conjugated double bond. So whenever we have like that, so I told you that we should call it as allylic position, right? Allylic halide. Okay, if halogen is attached on this carbon, not to this, so we can say that is benzylic carbon, benzylic halide. Okay, but it is attached to the alkyl group which is having alternate or conjugative position. If we remove this, see, this position is called, to the double bond, this position is called allylic position. So halogen present an allylic position, so allylic halide. So option 2. Here you should add this Cn minus H plus to this, so it will become OH Cn, cyanohydrin we can say. So now concentrated sulfuric acid. Okay, if we are adding this, so this OH minus and this H plus will be eliminates. So whenever this elimination reaction is taking place, okay, I will be writing that. OH, Cn, we have like this. So I am adding H plus to this. So what happens? OH and H plus removed as water molecule. Cn we have. So these two are forming water. So if it is eliminating from one of these beta carbons, hydrogen should be removed, like H plus should be removed. Therefore we are getting something like this. Again, so whenever we have cyanide group and upon hydrolysis, see, along with the cyanide group we have water from OH and H plus. So if we hydrolyze this thing, we will be getting a product like this. So we have option number 3 for this particular question. Okay, so I hope it is clear without any confusion. Homoleptic heteroleptic complex means, homoleptic means the ligands attached to the central metal atom. So in the coordination complexes, we will be representing metal complex in the square bracket with metal and some ligands, right? So if all these attached ligands, if they are same, then we can say it is homoleptic complex. If these are different, we should call it as heteroleptic. See here, diamine, cobalt, diamine, chloride, nitro. So different ligands are there. So this is not the homoleptic, like that. Okay. Potassium trioxalato aluminate, all are oxalate ligands. So it means this is homoleptic. So here triamine, triaqua. So amine ligands are there, aqua ligands are there. So I can say this is heterolytic. Okay. Pentaamine carbonate. So one like amines are penta, 5 amines are there, one carbonate is there. So this is also heteroleptic. All the ligands attached to the central metal atom should be same. Then only we can say homolytic. So option 4 is most suitable answer for this question. So weight of 2 moles of organic compound which is obtained by heating sodium ethanoate, sodium ethane, like 2 carbons, ethanoate. Okay. So upon heating this with NaOH in presence of CaO, calcium oxide. So this process is what? Decarboxylation. We discussed very clearly about this thing in hydrocarbon chapter. Again you can watch. So till now we have seen 2 questions or 3 questions from hydrocarbons, right? Okay. In this paper only we have seen 2 or 3 questions from hydrocarbons. Okay. So if you want to learn more about hydrocarbons very effectively, you can watch the hydrocarbon series. There are 3 videos where I have covered maximum number of questions in the 3rd part. So from in the first two parts, topic is discussed, concept is discussed, and the questions related to that each topic also discussed. Okay. So you can you can have a look if you are interested to watch them. Okay. Now, so these what it will do? It will decarboxylate. So in decarboxylation, just remove the CO2 part. What is the remaining group? CH3. So add one hydrogen to that, CH3H. That's it. Okay. And byproduct is Na2CO3. So like this we got. They are saying 2 moles of this compound will give. So here if it is 1 mole product will be get. If we 2 mole, if we take 2 mole, it will give 2 moles of this product. So that is CH4 is nothing but methane now. So we got 2 moles of methane. So 2 into what is the molecular weight of methane? So 12 plus 4, 16. That will be 32 grams of product is formed. So first option is correct for this question. Okay. I hope it is clear. Okay. Then next you can give a try for the other one. Give a try for this question. So this see, whenever we have carbon 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 oxygen carbon kind of thing, so we should call it as ether bond. What is that? Ether. So it's a functional group ether. So here carbon oxygen carbon is there, so this is ether derivative. Okay, so ether is a functional group here. So when we are adding HI, again we discussed this very nicely in SN1 SN2 reaction concept. You can go and watch that if you are interested. Okay, so to this oxygen, here we have strong acid, it liberates H plus ion. Okay, so this H plus ion will be taken by this oxygen. Okay, now oxygen will be having a positive charge after taking this H plus, right? So what is that species called? Like this we have, right? Okay, now look, so it is in the acidic medium, process is taking place in acidic medium. So now more H plus ions will surround this oxygen. Now it is having positive charge, so we need to break this bond, we need to break this carbon oxygen bond so that the oxygen positive charge will get removed, right? So therefore it will drag the electrons from here as well as here, but which is weaker bond? See, after breaking this we will be having a benzylic, carbocation this side. If we break, if I break from this side and if I break from here, what I told you, we will be having a benzylic carbocation, and what is the remaining part we have? We will be having a this side part is what? Like this, which is attached with the oxygen and hydrogen. This you can write, you can keep aside. Okay, what about the other part of it? What about our other part? So it will be taken that side and gives a carbocation like this. If I break this side, so this carbocation is highly unstable, so therefore we should not break to generate a unstable carbocation. Always breaking takes place to generate a more stable carbocation like this, which is called as benzylic carbocation. Okay, so now, so if we break this side, we will be getting a stable carbocation. Okay, so and the remaining part will be phenol. So the product from this side will be phenol. So phenol is there here and here. What is the remaining part? To this carbocation, that iodide ion should be added on this. So therefore we will be getting benzyl iodide like this. Okay, so benzyl iodide, so it is given as methyl group. This is not correct. So option 2 with benzyl iodide, so which is from the nucleophilic substitution reactions of ethers. Okay, when treated with HI. Okay, you can watch about this in the nucleophilic substitution reaction. See guys, I made a video on SN type reactions, nucleophilic substitution reactions. There will be at least 1 or 2 questions from the topic. So in the upcoming NEET and EAPCET exam, definitely that if you watch the topic, definitely you can able to tackle the questions on that concept. Which among the following will be most readily dehydrated under the acidic conditions? Okay, this is also interesting question here. See, dehydration in acidic medium. See, if I remove water from here like OH and H plus, so we can get a double bond here, and if I remove from here also we can get a double bond here. Okay, for this if I remove we will get a double bond here, or here if we have acidic hydrogen here, so if we remove, so we will get a double bond here. Okay, so the process will happens in this process more readily, because see, after removing the 2 hydroxy groups, we are getting a conjugative system like this, which is more stabilized by the conjugation. Therefore dehydration readily takes place in this option. Okay, I hope it is clear. Okay, next, the equilibrium concentration of species, given respectively delta G naught. So this is easy, right? So what is the relation between delta G naught and equilibrium constant? Delta G naught equals to minus RT ln K we are writing, right? So you can take like this, or you can also take it as minus 2.303 RT log K. K means equilibrium constant. So in this, what is K here? K means equilibrium constant, we have to take it as concentration of products by concentration of reactants. So it means concentration of C by concentration of C into concentration of D by concentration of A into concentration of D, concentration of B at equilibrium. So at equilibrium they mentioned now. So what is C concentration, D concentration they mentioned. C concentration is given as 10 and 6 into 10, and in the denominator AB is 2 into 3. So 2 into 3 6, this 6 cancel. So K value is 10. Okay. So now here we have minus 2.303. R value they told to calculate in terms of calories, and R value mentioned. So 2 calorie into temperature is 300 Kelvin. Okay. Into log 10, K value is 10. So log K, log 10 is 1. I am writing like that. Okay. So this will becomes how much? So minus 2.303, let us take 2.3 into 2, okay, into 2 3 is 600 I am writing. So I can say 23,230 into 6 we can write like this. So you can simplify this, you will get any of these options, 4 options. So 0, 8, 1, 12, 13. So you will be getting an option to near to this minus 1381.8 calories. So that will be the suitable answer for this question. Okay. I hope it is clear how we are simplifying this. So there will be a question again on this delta G. Either they will ask you a question on this delta G. What is the relation for delta G? The delta G equal to delta G naught plus RT ln K, like ln Q. Okay. ln Q means reaction quotient. At equilibrium this delta G will be equals to 0. If it is 0, equation is equals to 0, then if we send this side, delta G naught will becomes minus RT ln K. This is what you have taken here. Okay. So this is the one equation where you can expect a question. And one more thing is that spontaneity process. So delta G, what are the conditions? Delta H minus T delta S. So what are the conditions for a spontaneous process? For a spontaneous process, delta G always should be negative. In order to make this negative, delta G can be what? Delta S can be what? What are the conditions it can be? So based on this equation also you can expect a question. Okay. So we can call this as spontaneity of a process. You can focus on this topic also. Nutrient deficient water bodies lead to eutrophication. Eutrophication leads to decrease in the oxygen level of oxygen in the water bodies. No, here you can see eutrophication leads to decrease in the oxygen. Yes, this is correct only, but eutrophication means what? It is nutrient rich, not deficient. This is rich. Okay, therefore I can go with option. Statement 1 is incorrect, statement 2 is correct. 1 is incorrect, 2 is correct. So option number 3, true statement, second statement is true, first one is false or incorrect. What is the relation between delta H and delta U? So delta H equals to delta U plus delta PV, we can write like this, or in terms of delta Ng we can write delta U plus delta Ng RT, which is equals to delta H. So this is comes from ideal gas equation, PV equals to nRT. From there we got this relation. Okay. So first option is correct for this. Peroxodisulfuric acid. So what is the formula? H2S2O8. So if you calculate for these, you will be having the charge or the oxidation state of sulfur, average oxidation state as +7. So it is not possible now. So for any element, the maximum oxidation state will be equals to the number of valency electrons present in that atom. For sulfur, how many electrons are present in the valency? Like 3s2, 3p4 we are writing. So it means 6 valency electrons are there. So but if you calculate average oxidation state by taking 2x, like 2 plus 2x plus 8 into minus 2 will be giving us, if you calculate this, you will be getting x value as the +7, which is not possible. So it can be a maximum of +6 or lower than that, but cannot exceed, should not exceed +6. Okay. So in this case, whenever we are calculating like this, whenever the calculated oxidation state, the average oxidation state which is coming from this normal calculation, if that oxidation state is greater than the maximum oxidation state shown by that particular element, there exists one peroxy linkage. There exists some peroxy linkages. Therefore, in this molecule, a peroxy bond is present. So I am writing S and S. So I am writing a peroxy bond between them like this. Yes, done. Next, how many oxygens are still more need to be placed? 6, right? 1, 2, 3, 4, 5, 6. So this is a structure. So it is having 2 OH, 2 SOH and 4 SO groups and 1 OSO. So A3 you should choose. So once again I am explaining for this. Look at here. So if the calculated oxidation state is calculated, means using this formula, normal concept, redox reaction we study now, that concept if we use, that is what the calculated oxidation state is greater than the maximum oxidation state of an element, maximum oxidation state. Okay, maximum oxidation state. Okay, in this case peroxy linkage, for example M is an atom, M is another central atom, like here 2 sulfurs are there now, like that. If 2 atoms are there, between that we can have one peroxy bond. Okay, you can take like this. And the next, if calculated oxidation state equals to maximum oxidation state, there we can expect one oxy linkage, MOM kind of linkage. Okay, now if the oxidation state, calculated oxidation state is lesser than the maximum oxidation state, there we can have only MM linkage. It means there is no oxy. Okay, for example sulfurous, so it will be having only one sulfur atom now, so there is no issue. Okay, sulfuric acid, we know sulfuric acid, you can write like this, OH, OH. Okay, so 2 OH, 2 SOH and 2 SOH, 2 SOH, 2 SO. So I can go B4. So with this, let us find A3, A3, A3. Done. This you can remove, and B4, and the next pyrosulfuric acid if they say. So pyro means heating, you can consider. Sulfuric acid formula is there, H2SO4 is there now. Okay, just heat this by taking 2 moles. So whenever you are heating, just remove one water molecule from this formula. So total how many sulfur atoms are there? 2. S2. So it should become O8. It should become H4. But what I told you, remove one water molecule now. So it becomes O7, S2, H2. So this is a formula of pyrosulfuric acid. So this will be the formula of pyrosulfuric acid. Now pyrosulfuric acid having 2 sulfur atoms, just calculate the oxidation state, you will be getting +6. So in that case one oxy linkage will be present. Okay, now one oxy linkage will be present, that's it. So we got the option directly. So see why I am saying one oxy linkage. For sulfur maximum oxidation state is +6, the calculated oxidation state also +6. Whenever calculated oxidation state equals to maximum oxidation state, there exists one oxy linkage. If it is greater, peroxy linkage. If less, no oxy linkage, direct MM linkage, like say atom to atom linkage will be seen. Okay, so I can go with C1 option number 1. Okay, that's it. So this is how you can do. The major product obtained in the following reaction. This is a reaction. So these are the options given. So what is this? Tollens reagent now. So Tollens reagent converts aldehyde groups to carboxylic acid, but it will won't disturb ketone group. So where do we have? See, ketone group not disturbed, carboxylic aldehyde group converted into carboxylic acid group. So option number 2. Next, which of the following compounds are aromatic or Huckel rule is obeyed? Yes, first one naphthalene is obeyed, this one also obeyed. This is anti-aromatic, aromatic. This is COT, cyclooctatetraene, which is non-aromatic, which is having tub shape. Okay, this is incorrect. This is anthracene, this is also obeyed. So 1, 2, 3, 4. So 4 is the answer. So for proper or clear cut explanation on this aromaticity, see, there will be definitely a question on aromatic compounds, right? In the exam, in any exam you are going to attempt, there will be definitely a question on aromatic compounds. Just go through the live session where I have explained everything clearly regarding the aromaticity. Just go through the playlist, just click on the that channel logo and you can go to the live sessions. So there you can see aromatic nature by Ajay Sir. So from that, definitely you are going to attempt, if you watch it properly and learn it properly, so you can definitely have 4 marks in your hand in the upcoming NEET exam, and also for EAPCET you can score at least you can at least answer that question properly. Okay. The most stable complex, how can we do this? How can we do this? See, here there are many factors. So here, what is the oxidation state of cobalt? +3. Here also it is +3. Find the oxidation state. Here also it is also +3, cobalt +3 in all the cases. +3. Here also it is +3, cobalt +3. All the cases it is +3. Now all of them are having hexa coordination, right? Hexa coordinate. How many ligands are there inside? 6. So it means hexa coordinated complex, or I can say octahedral complexes. Okay. So in this case, we need to check if there any chelation is present, like ring is formation taking place. See, in the second option we have 2 ene ligands. It means cobalt will be having ethylene diamine. Ene means what? Ethylene. Ethyl means CH2 group. For one side NH2 group, another side also NH2 group is present. So these lone pairs are donated and this lone pairs also donated. See, we got a 6-member ring, 1, 2, 3, 4, 5. 5-member ring we got. So this side also we can get a 5-member ring. We can get a 5-member ring like this. Okay, like this. So and here chlorine atoms. So due to the presence of these chelations, these rings, the compound is highly stable. So I can go with second option. The next, so will you try to balance this reaction? So first of all, find the oxidation state. So here it is having +6, here it is having 2, 3 just 6, +2, +4. Okay. Now write the balanced equation for this. How can we do? So +6, +4, done. Then next, then what we can do? So we can take 1 mole of chromium. So let us try here. हाँ, 1 mole of chromium we can take. SO3 2 minus Vihana. So it will be giving 2 moles of Cr+3 they mentioned. Okay, and then next, do not take A, B, C, D, directly write the product, whatever the products are there. So after that we will compare the equation, final equation. H2O you can write, these are the products they mentioned. Okay, for this here it is +6, here it is +3, here it is +4, here it is plus how much? 6. Like this we can find. First of all, find the oxidation state. Now from here to here, how many electrons are changed? So from here 2, 3 ja. So for 1 atom it is 3, for 2 atoms it is 2 into 3, 6 electrons are changed. From here to here, how many? 2 electrons are changed, like gaining and losing and gaining of electrons taking place. Now that is what I am saying as electron change. Like this you can find. Okay, so in order to make this number equal, here it should be 6, here also it should be 6. So during a redox reactions, number of electrons lost and number of electrons gained should be equal. Here it is 6 electrons lost, 6 electrons gained in this process, so it should lose 6 electrons. So in order to make this 6, I am multiplying here with 1 and this equation with 3, therefore it is also become 6. I hope it is clear up to here. So what we are doing with this? Okay, so now what is the equation we can get? Cr2O7 minus 2. So I am doing directly without like following the rules, I mean exact like steps of the rules. So what are the steps we have in acidic medium? First find, I mean, first balance all the atoms like this. How many chromiums? 2 chromiums, here also 2. That is already done. 1 sulfur, there also. Now, next, number of hydrogen, like number of oxygen atoms should be balanced. Those things are there, no? That is what the rules I am saying. Okay. So here, which this equation I am multiplying with 2 now. So it will become 2 here. It will become 2 here. And also this equation means from here to here, now this is also become 2. Like this we should multiply. Okay. And the remaining will be 1 into 1. That's it. Okay. Up to here it is clear. Now look here. How many oxygen atoms are there here? 7. Okay. Therefore number of electrons are now become equal in oxidation and reduction. So 7, and here it is 2 3 is 6. So it will be what? 14, 12, 13. This side how many are there? 8. After 8 here how many are there? Only 1. So 9 only we have. So how can we make this 13 equal in both sides? So we can take this as, see, 8. C by 2 they are saying, no? Yes, we can make it. Okay. C by 2 means, if I take 4, how much it will become? 8, no? It will become. So here, yeah, fine. We are getting 8 here. So 8 means, these are 4 plus 8. So it will be 12. Here 7 plus 3 to the 6, 13. So what is the value for this chromium we got? Okay, 1, fine. So do we made any mistakes? No, right? 4 to the 8, 9. If I take 5 here, what is the answer we can get? 5H2O. So 8 plus 1, 9 it will be. So if I take this as, okay, let us come to this back again once after looking these questions. Okay, identify the final product D obtained in the following reaction sequence. Okay, so this one, aldehyde upon treating with lithium aluminum hydride, what we can get? So we will be getting alcohols. Aldehydes always, aldehydes CH3 COH converts into lithium aluminum hydride. So this gives what? CH3 CH, again here 1 H, here it will become OH, right? So alcohol is formed. So alcohol is a product. So upon heating means what? Upon adding H plus and heating should be taken like a default manner. So removal of water takes place, and what it will be giving? CH2 double bond CH2. So this is the alkene which is got here as the product B. Okay, so this B product upon treating with HBr, so if we treat this with HBr, so we can get CH2 CH2. So on one carbon you add Br minus, and other carbon you should add H plus. So this is what like hydrohalogenation, like addition reaction, electrophilic addition. So to this alkyl halide, so here we have alkyl halide here. So this should be treated with bromobenzene. So bromobenzene if we take, so if we take this bromobenzene, so what is the product formed here? So with sodium diether. So sodium diether means just remove these two parts. So what we can get? CH3, this is H2, CH2. This is what? Woods reaction, right? So we discussed about the Woods reaction again. So this will be the final product. So benzene with ethyl group, ethyl benzene. So option 4 will be the correct one for this. And the next, this is about the paper. So we need to just check for this question first actually. Yeah. So we can do this once again. Okay. So I think everything is clear in this paper discussion. So we will be doing this question once again. So let us take chromium, Cr2O7 2 minus plus SO3 2 minus plus H plus gives rise to Cr plus 3, 2Cr plus 3 plus SO4 2 minus plus H2O. So this is what the equation given in the question, right? Okay. So what are the coefficients A, B, C they mentioned here, right? Okay. So how many chromiums are there? 2 chromiums. So it is balanced 2. Okay. So first of all, what we need to do? We need to identify the oxidation state. For it is 6, and for this will be 2 3 6. So it will be plus 4, and here plus 3. Here it will be plus 6. Like this you can do. Okay. Then next. Now how many chromiums? 2 is it is fine. So sulfur it is 1, here also 1 sulfur atoms is also fine. Okay. So now how many electrons are changed from here to here? So it will be 3, number changed is 3, and 2 atoms, so 2, so total 6 electrons. Okay. From here to here how many electrons are changed? So 2 electrons, okay, and 1 atom, so 2 electrons are changed here. So but lost and gain should be same. So in order to make this number same, so I should multiply with 3. So this is what the mistake we did in the previous case. Now I should multiply with 3. So therefore it will become same. So what is the equation I should write now? Cr2O7 2 minus plus, so this should be multiplied with 3. So 3SO3 2 minus plus H plus gives rise to 2Cr plus 3 plus this number should be multiplied this one and also this one. So 3SO4 2 minus plus H2. So this is what the equation we got. I hope it is clear up to here. So now how many oxygen atoms are there? 7 here and 2 3 3 is 9 here. So total how much? 16 here. I hope it is clear how many oxygen atoms are there? 16. And this side also you can check. 4 3 is 12. So 12 are there, so it should be 16 here. So it means how much number I should write here? So it is 12, but we need to make it 16. Therefore I can take 4 oxygen, like 4 water molecule, it will become balanced number of oxygens. Here 16 water molecules, oxygen atoms, here also 16 oxygen atoms. It will be clear. I hope now it will be like we are on the track, right? So sometimes, yes, so we may face difficulties, I mean we will do some small mistakes, so we should give some space to that, I mean go to the next question, come back and solve it. So this is what the technique I used here. So we got, finally we got the answer. Okay. So here it will be 12 oxygens, so plus 4, so total 16, it is balanced now. So that's why I have represented here 4. So now what about oxygen atoms are balanced, now what about hydrogen atoms? So here it is 4 to the 8 H plus like 8 hydrogen atoms are there on the product side, but here we have only mentioned 1 hydrogen atom. So in order to make it 8, just add 8 H plus since it is acidic medium. So this is what the step you should follow. So now what are the numbers here we got? So here the coefficient A is 1, okay, so A is 1, okay. Next B, what is our B? I just want to zoom it. So what is our B here? So B should be so B should be what? So B is 3 here, so 3, and the next C is what? C is 8 here, that's it. So A1 1 3 8, so which is there in option number 4. Yes, this is how the like numericals has to be done. I hope it is clear, there is no confusion in this kind of questions, right? So I hope the session will be helpful for you for your preparation. Yes. So whenever you are facing difficulty while solving a question, so just get relaxed, put it aside and go to the next question, or just put it aside and go through other questions, or take some break, take some water and come back to that, and you will definitely able to solve that question if you know the concept. Okay. So always believe in concept, but not in the some other stupid ways. Okay. So I hope everything is clear here, and if you require any help or any difficulties are there to understand the concept, write in the comment box. I will be discussing in the next sessions. Okay. Thank you for watching.